Hi there, I'm Alexis. So today I'll be talking to you about our tech stack, but also about how our GraphQL is set up and lots of modifications we've had to do to make it work for us. Before that, I'd like to tell you a little bit about myself. I've been here at Moonpig for 4.5 years, currently a principal engineer within the enablement space. And I cover the infrastructure team, platform team, and our developer experience team, which we're hiring in. Before I joined Moonpig, I was a cybersecurity engineer, did all of my specializations at university in cybersecurity, but I still have a love for security, but I've decided that the best way to do security is actually by being an engineer. In my free time, I love maintaining open source projects. I've been going to FOSDEM for as long as I can actually remember going to FOSDEM, because I used to go as a child. I currently maintain the Kioxide project along with fellow friends. If you don't know what the Kioxide project is, it's basically a replacement of Keybase. It's a federated version of online identity proofs, which basically allows you to share your identity across the world without having to host anything with anybody, specifically not Zoom. I also maintain one of the few diagnostic tools. When I deployed it, it was the only one for the WKD protocol, which allows distributing OpenPGP keys via well-known directories on your websites, which basically makes OpenPGP distributed and federated. There's loads of other projects, most of them related to PGP, and then a few about deployments and making life for developers easier, but I didn't want to list all of them. So Sush told you a little bit about Moonpig. I had a joke, but now he's taken it away. Moonpig is the website you think of when you've forgotten your Valentines. However, we're actually a really modern tech stack. When I joined Moonpig, I was impressed by how modern it was. So we've got 17 teams building this tech stack, delivering features across 3 clients, which are duplicated for each of our brands. They use the same code base, but they are basically configured for the different brands. So if we ever did buy another company, we would be able to brand them. I hope it doesn't happen because that was the most complex project I ever worked on, but it's a thing we can do. Our website is a semi-complicated, monolithic but not monolith website running Next.js. Currently is 5 web apps, all managed via a single monolithic repo, but they're technically split from a code base point of view. All of this is backed by a single API for all of our clients. So we don't have APIs to our specific clients. We build everything for everything. And they're composed of 26 micrographs. Each of those micrographs represents one of our domains, and all of our domains are fairly complex. I'll talk a little bit later about what that enables us to do, but it's mostly around making sure our teams can work independently without having to step on other people's toes, whilst building a schema that works for all the apps, and no one has to then go and understand what you've built because they can just read the graph. One of the things that's pretty impressive about Moonpig is that we follow fairly strict CI/CD approach, and so we deliver on average 60 releases every day. Some days a lot more, and then some days less because we're worried about taking down the website. But that's sort of what we've been doing. In reality, what we've built is a hyperscalable multi-region active-active system, which, like I said, delivers and serves all of our clients at the same time. But we've built it with plans to keep everything in a way that allows our teams to build quickly and iterably. I'll be going into each of these points in more detail on in the following slides. And Do you mind if we take the questions at the end? Yeah. So how do we achieve hyperscalability and multi-region deployment? We took an approach of serverless first at Moonpig. You won't find any EC2s or any VPCs actually at Moonpig. We hate VPCs. We hate doing networking. We've utilized Lambda for our compute, SNS, SQS, and EventBridge for our event messaging and brokerage. And for our databases, we prefer DynamoDB over everything. But sometimes you need to use S3 for those large objects. And finally, some of our use cases really required relational databases. So we use Aura Serverless v2, which annoyingly makes us build VPCs. From a routing perspective, we've got customers across the entire globe. We have customers in the UK, Australia, US, and also the Netherlands. And I always forget Ireland. All of this is all this traffic, we route it using Route 53 geo-based routing. This allows our system to be built into multiple regions. Each region basically contains an exact copy of the data and the systems, which makes it active-active. This means that we could lose an entire region. AWS, please do not take down the US one. But if they did, hopefully we would be able to fall back to the US and our customers would have terrible latency. From all of the services that run HTTP, so basically anything that's an API, be it that talks to our clients, all fronted by CloudFront. CloudFront gives us a cache next to our customers and also provides us with some security tooling. This approach has allowed us to build a system that scales directly with our traffic patterns, which are extremely peaky. This graph on the bottom shows in blue the number of users visiting the website or using the apps on a daily basis. And as you can see, there's a big spike there. That's one of our busiest days, and other times not very busy. And if you zoomed into hourly rates, you would notice that our customers buy a lot during lunchtime, for example, and in the middle of the night, no one's using the website unless you're a script kiddie. And what that's allowed us to do is to keep our costs in line. Our costs basically follow the traffic pattern. So you can see here in red, that's the total cost for the system following exactly the peaks and troughs of our system. And then one of my favorite things, because I did the work, is here you can see it dips down. That's me optimizing the backend. And when you optimize your Lambdas, you immediately convert that into savings. So one of the coolest things at Moonpig is if you want to do technical debt and optimizations, you just say, I'm saving you thousands of pounds a day, and everyone lets you do it. In order to enable our teams to work in silos and deliver quickly, we took two approaches. The first is we prefer buy over build. We really don't want our engineers thinking about infrastructure problems or IT problems or managing EC2 instances, patching servers or whatever it might be. We don't even want our platform team doing that, and I'm part of the platform team. What we want them doing is focusing on the business problems and solving those business problems. And so picking serverless, AWS first. If we can't do it in AWS, we'll pick a SaaS provider and just use a third party. We as much as we can, try and not build the thing. The other approach is we've built an event-driven architecture, and we've also gone for a distributed data model. This has allowed our teams to build loosely coupled domains and means that our teams can work on those domains without stepping on each other's toes. Communication between the domains use events and commands, but they all follow a strongly typed schema. This means our teams can't break the contracts between their domains, or at least it's a change when they do that. that everyone can pick up. Each domain has its own set of data, and when it needs data from another, it listens to events from that other domain and generates its own data projection from there. So we're not sharing database resources between, not share those data resources between our database, between our domains. So if I kill my DynamoDB because I didn't like it, or because it was built wrong, or I wanted to change the shape of it, the other team would never be affected by that, only my team who owns that domain. This model, however, has some people call it a downside. We have to accept eventual consistency. At Moonpig, we really enjoy eventual consistency. We build around it. We'll use Saga patterns to get around some of the quirks it might have. We really prefer having eventual consistency up all domains. However, being an e-commerce website, we do have a few things that don't like eventual consistency. For example, payments. So in the world of payments, we do have some synchronous calls, but we try and avoid them as much as possible. Another thing is sometimes when we want to avoid that strict coupling between the domains, we sort of let the client do the orchestration and do that coupling itself. So when we use a federated graph, we'll call try and like move some of that logic into the client. It does make our clients a bit fat. If you talk to some of our engineers, they really hate it, but it's a sort of like necessary evil. So to orchestrate all of these things together into a single API for our clients, we've gone ahead and built a federated GraphQL API. We leveraged the Apollo Federation schema. This was something that I think was one of the few federation schemas available when we started this project. However, we no longer use any of the Apollo services to do the schema stitching or look at the schema or do the introspection side of things. We've solved all of that in-house with our own tooling or open source projects. The Federation Gateway is actually a fairly heavily modified version of the Apollo Gateway library. So we still pull in the Apollo library, but we've modified lots of parts of it, mainly to integrate better with AWS. Because of the way we don't want to, because of how we prefer to buy things in Amazon, we wanted things like our logging to be in Amazon and our metrics to be in Amazon. So we've got custom metrics built into the gateway that go straight into CloudWatch. These metrics cover everything from using our like the usage of the different queries to how often your query gets cached, how often your query hits the query plan cache, all of those kind of metrics. Another thing we've had to get around is many of the weird AWS quirks. There is URI length limits in CloudFront, for example, and when you have massive queries, which some of our clients decide to send to us, we've had to get around that. Same for Lambda size responses. You're limited to 6 megabytes. I don't know if anybody knows, but JSON's pretty bloated, and pretty quickly your queries become 6 megabytes in size. So we've got a few things that allow us to deal with that problem. Most of it is basically refusing the request, but some of it is like we do compression within the Lambda before we ship it through the API gateway, and so we don't hit that limit. That someday is probably going to break, but so far it works. Finally, all of our micrographs run the Apollo subgraph library. We don't touch it, we don't modify it. It's basically what comes out of the box. However, in order to enable our teams to use CloudWatch, we've built a load of custom plugins that like standardize logs, standardize metrics, and etc. Things like names and all of that, so that our centralized Grafana can pick those things up and let teams build pretty dashboards. We also have a few other plugins that deal with some of the special headers we use at Moonpig. And then we've also recently built a few plugins around tracing in order to enable AWS X-Ray. Again, it's all about integrating better with AWS and leveraging AWS as much as we can. So what's next for us? We're currently trying to replace a lot of our Apollo stack. We've noticed the GraphQL community has been releasing lots of really fancy new things, and our stack is starting to look a bit old. I can't believe it's old. It's literally, what was it? When did we do a new platform? Like 4 years ago. So it sucks that it's getting old, but we do want to keep up to date. And so some of our teams are starting to look at newer libraries for their micrographs, for example. So we've recently passed a ADR that allows our teams to use the Hot Chocolate library, which actually enables those teams to stop writing TypeScript and go back to the language they like, which is C#. In the current instance, what they've got is a GraphQL Lambda, which is running TypeScript, and then basically does REST calls to another Lambda, which is running .NET, because they really wanted to write .NET. So those kind of optimizations are what we're looking at now that Hot Chocolate, for example, fully supports the Apollo Federation v2 schema, which it didn't. We're also always looking to improve our gateway, now more specifically around performance. We're starting, now that we've got this new platform, we're looking to improve upon it, especially from a performance point of view. We're really interested in lowering our page load times and not only within the website, but also within the apps, making things more responsive. Because nearly every, I did say at before that some of the apps are a bit fat, but actually a lot of the logic happens on the API, and making the API fast makes the website a lot faster. That optimization you saw me do there before was me optimizing the gateway, which led to lower times waiting for the website to render, which led to the cost of the website going down. The ways we're doing this is we're starting to do things like profiling our gateway and looking for the hot paths in there, and potentially going to be modifying the Apollo Gateway library itself to see if we can't make some performance optimizations there, especially with hot paths that we hit. And also just find other optimizations. Maybe there's something in the custom code we've been writing that slows things down. The other thing we're looking at is finding an alternative for the Apollo Gateway. I don't know if you've ever been to the performance page of the Apollo Gateway, but it basically tells you don't use Apollo Gateway. And it tells you to use Apollo Router. So we've looked into Apollo Router. Apollo Router is written in Rust. It's very cool. And as a Rust developer, I love it. One day we will do Rust at Moonpig. However, but one of the beyond the language barrier, the other problem we've got is that it's not made for running on Lambda. So we found a few people that have done some pretty awesome modifications to the library in order to make it run in the Lambda. Though it seems to be abusing the testing library that was built for Apollo Router, which is an interesting way of getting around it. But it's actually pretty fast, even with those weird quirks. You see nearly a 50–60% improvement in speed. We've also tried out Cosmo Router, which was a lot easier to implement from WindoGraph. Cosmo Router is written in Go, but it's been written for AWS Lambda, so it's fairly easy to implement from that point of view. However, again, there's sort of a language barrier considering Moonpig is a TypeScript.NET house. And I don't know any Go, so I looked at the code and didn't really understand it, but it did do the schema federation for us, so maybe we just blindly run it, I don't know. Like I said, it's been really difficult to find an alternative for this, to the point that I've started coming up with diagrams on how to make the gateway run on AWS Fargate, which is their serverless offering for containers. I'm not convinced that it's the right solution. It does make the price of things a lot higher and etc. But it's based on some math, it looks like it's the same. Sometimes it doesn't look like it's the same cost. So yeah, that's our plans for the future. So I decided to write a key takeaways page because I was hoping you'd learn something, or if at least you enjoyed any of it. You might remember these bits, but the important parts are serverless has allowed us to build a system that allows our teams to focus on business problems. When you're building with AWS Serverless, you don't need to think about the 90%, like the 95% of problems that most engineers run into around, like, do I have the right IP address? Do I have the ports open? All of those things basically disappear, especially when you've got a good developer experience. The other thing is, obviously, it's allowed us to scale our systems directly with our traffic patterns, which means our costs are pretty low. Federation, some people hate it, some people love it. We think it's enabled our teams to work entirely independently while still working on the same thing. It's really allowed us to stitch our multiple domains together into a single place, meaning that people building the front ends don't need to think too much about how it works in the back end, and it allows the teams that are working on the back ends to be able to deploy things without really thinking about how the people are using it in the front end. And finally, it's really important that companies continue like changing their tech stack and constantly evolving it. For us, it's, like I said, we've had we call this the new platform, and it's about 4 years old, but it's always been improved on, mainly because we don't want to lose out on the investment we've done. There's a QR code here for the Moonpig blog posts. Plenty of my colleagues have gone into great detail on everything I've talked about. There's a set of blog posts called the GraphQL Journey, which actually talks about how we went from REST to GraphQL. I didn't really want to talk about it too much because I wasn't there, but they're a great read. And then we also have a podcast, which I don't have a QR code for, which is findable on Spotify, Apple Podcasts, and etc. And we talk about tech mostly. So it's all a tech podcast. I did a small podcast specifically on event-driven architecture and going into more detail there. And I'm pretty sure there's one on GraphQL in there. I wouldn't be able to tell you which episode it is, but I know it exists. Finally, if any of this was of interest and you want to work on it, we're always hiring. Sush gave you the list of roles available. One of them is a senior software engineer in one of my teams. And that's the team that does the developer experience side of things. So making all of this stuff possible for all other developers. And finally, my QR code, my Kioxide profile is there as well. If that's not working, my website is streambosonic.com. Thank you very much.
Thank you, Alexis. That was fantastic. Really, really interesting. I love to see an interesting use case of Lambda with such spiky traffic. Very cool. Okay, so we're going to take a break for a bit, and then we're going to come back about 8 o'clock. So